All right, when it comes to writing the next lab report, let's learn from our mistakes from the first lab report. Remember, if you were graded on Blackboard, which most of you were, there are comments on Blackboard about your lab report, actual comments about things that we noticed, and let me point out, not just the rubric, but actual comments about changes you can make. So the basic rules for the lab report can be found in Appendix B. Make sure you read thoroughly the how to write a lab report section and the rubric. But we're going to have Times New Roman size 11. You could also do 12 if you want. 1.5 spacing between lines. No longer than 2 pages, and that includes your figure, but you can have, you should have a 3rd page of your appendix, which is your Excel data. You need to have at least 2 primary sources. That's a primary journal article, not a website, not a blog, not an article from a magazine, but a primary research paper. One can be one of the ones that I have provided. And you also need to cite the manual and the textbook. So you have your title, which should be clear and concise. Some of you had titles on the last paper that were not clear or not concise. So it needs to clearly tell me what the paper is about. A simulation of, it shouldn't just be simulation of thermoregulation or thermoregulation, or you should tell me what the paper was about. A simulation of what exactly? Tell me, and do it as clearly and concisely as you can. Under the title, have your name, your lab partners' names, and the day and time of lab. Please be sure also that you upload this as a PDF, not as a Word file, okay? These reports should be done individually. Do not share graphs with your lab mates. Do not share captions with your lab mates. Do not share anything with your lab mates. That'll get you in trouble very quickly, and then everyone gets 0. So we don't want to do that. You need to write in the 3rd person passive voice on this one. So rather than saying, I made a clay ball of, or we made clay balls of white and black clay, simulated organisms of red and white clay or whatever it was that were used in this experiment, right? 3rd person passive voice. You might have to Google how to do that if you're not sure. I guess there's a light behind me. My hat keeps disappearing. All right. So also follow any additional instructions that I or your instructor gives when talking about this lab report. Now, the introduction. The introduction starts broad and gets more specific as it goes down. So on the first lab report, a lot of people had introductions that focused on their experiment rather than the topic. You need to introduce the topic. Discuss thermoregulation. Not this experiment studied, but no, I don't say that. You can start with the word thermoregulation. Thermoregulation is the process by which blah, 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 blah. Talk about radiation or convection, whatever it is, everything you need to introduce so that your materials and methods and your discussion makes sense to the reader. Pretend they have not heard about thermoregulation yet, and you need to tell them everything they need to know to get your experiment and understand why it's important. What was the organism or the model? If you can tell them what the model was and what it was simulating. If it's a real organism, tell us what that organism is that you were simulating. And then finally, what was your research hypothesis? Research hypotheses at the minimum have to have the word if and then in them. So if then, so if, and then you have your hypothesis. And by hypothesis, I mean you have to have an explanation there. If you don't have that, you're going to get very few points for your hypothesis. A lot of you just gave me a prediction on the first lab report. So if, now an explanation, if fur acts as an insulator, trapping air near the body, then organisms with fur will lose heat more slowly than organisms without fur. So the if has to be followed by an explanation, not a prediction. The prediction comes after then. Okay. And you can also have the word and in between, which is fine too. If fur acts as an insulator, trapping hair near the body, and organisms are with and without fur are heated up and then their rate of cooling is tested, then organisms with fur will heat more or cool off more slowly. That's fine too. But at minimum have if followed by then. If after the word if is a explanation of why something will happen, and then a prediction after the word then. Assuming your explanation is right, what do you predict to see happen? All right, so here's an example of that. If then I left out the and. I'm leaving that optional to you. If you wish to do it, you can, but I'm not mandating the and part of the research hypothesis. Materials and methods. Do not list a series of ingredients like you're cooking. Once again, don't say I or we in here. Talk about what happened, or what, not what happened, but what you did. Beets were cored with a 3mm corkboard. Cores were then sliced to 5mm thick discs and rinsed. This is from a Bio 1 report, the example here. You're writing in that style, but you need to say organisms weighing this much and shaped this way, you know, whatever, with these colors of clay were placed this far from a heat lamp with a whatever watt bulb, right? All that information is important. How did you set it up? You want someone else to be able to read this and set it up themselves. You also have to tell me how you analyze the data. Was it a one-tailed t-test? Was it a two-tailed t-test? Was it a paired test? What did you do to analyze your data? And be sure everything is in metric units. Don't give me anything in inches or pounds, okay? The results section. You should write a paragraph about what happened. Include quantitative data like percent or fold change, and qualitative data if it's applicable, like if your clay melted or you saw other things occurring or you felt that things getting really hot. You can talk about that here. But remember, we don't say why things happened here. We just say what happened here. You also, in the written results section, in that paragraph, you have to have the p-value from your t-test. So what kind of test did you do? You tell me that in materials and methods. What was the p-value? Then you should also, within that sentence, within that paragraph, reference the figure, and don't do it clumsily, like as can be seen in paragraph or in figure 1. Just say, as this increased, that increased, boom, figure 1 in parentheses, period. Look at the examples of the papers we posted, how they reference their figures. The figure should also have proper labels and error bars. And the only way for us to see that when we grade it, if we're grading online, is to submit this as a PDF. Don't submit it as a Word file, okay? PDF only when you submit these virtually. And everyone has to submit one virtually, even if you're asked to turn one in person. So the figure should be below the written results section. It should have all the proper labels on the axes, including units, and it should have a figure caption. That caption should also have quantification of change, should tell me sample size, what kind of error bars those are, so mean plus or minus SE. It should also tell me the p-value. If you wish, actually your materials and methods, your caption, and your lit cited can be shrunk down slightly. If you need more room in your paper, your materials and methods, I accept up to size 8 font, or I mean as small as size 8 font. Your caption, don't go below 10-point font, but shrink it slightly so it's easy for me to tell your caption from the rest of your paper. And you can also shrink your literature cited section down to 8-point font if you wish, if you need more room. So far, we have told the reader about the topic. We have told the reader what we did. We have told the reader the raw data, what we found out. Now we tell them what it means, why it happened, and what it means, and how it relates to biology. These are the 3 big things here. What it means, or like why it happened, what it means, how it relates back to what we know about biology. If you don't do all those things, you can't possibly get a B, or let alone an A on the paper, right? So was your research hypothesis supported? Start there. So discussions start narrow. What happened in your experiment? What does it mean? And then you expand broadly and kind of tie it back to biology as a whole. Was your research hypothesis supported or not? Why or why not? Then using, explain why your data occurred using what you know about heat, thermoregulation, surface area to volume ratios, all that kind of background, that background you introduced in the introduction. Explain your data, why it happened, and in relation to what you talked about in your introduction. If you made any errors, don't spend more than 1 or 2 sentences most on that. I don't want a whole paragraph of how you messed up. Then relate your findings back to biology. So we talked about why things happen. Now tie it back to biology. Cite one of those papers. This is similar to how this organism works in the wild. Here's why it's relevant. Provide citations here. And then finally, a concluding statement. Overall, what did you find out? And I like to see at the end of a concluding statement, this is one of those things that the instructor can add, what you would do next time if you were going to build on this experiment. So the next experiment that should be conducted is to investigate, tell me what it is, okay? So your discussion starts narrow, your hypothesis, your experiment, what happened, why it happened. So as we get to why it happened, we're expanding, we're adding biological principles there. And then what errors you made, and then finally relating it back to biology as a whole, why it's important, how it relates to convection, conduction, how it relates to a real life organism known in the wild from another scientific paper, that sort of thing. Finally, your citations. Never, ever quote directly from a source, okay? You always paraphrase in your own words. And if there's one author, you cite something like this, their last name and the year the paper came out. 2 authors, you have it cited in the text like this. 3 or more authors, et al. Means and the rest. And this is in the text, like in your introduction if you're citing a paper. Here's an example of a citation down here. Ectotherms can control their body temperature by adjusting their posture relative to a heat source. Whitman, 1987. And then at the end of the paper, you have to format this correctly to get full points. You need to use hanging indents. If you don't know how, you got to Google it, okay? Organize all these alphabetically by the first author. Don't rearrange the author names from the paper. Arrange them by first author, okay? Let's see here. So journals are cited like this. There's examples of this in your manual in the appendix. Here are some example citations, but here's how they would look. Citations might look in order. Okay. So Allen is before Andrews, right? And Arnold is before Axsmith. Oops. And so you base it on the first author. And here's what I mean by hanging indent. This one's out here. The rest of this stuff is tucked in slightly. So this is the proper citation format. And I really prefer not to see websites on your citations. Cite the article, not the website where you found it, okay? It has to be a primary source. If you do use a website as a secondary source, that's fine. You can cite it properly. But for your primary sources, cite the article, not the website. Your grade ultimately will reflect the quality of your work and the clarity of your writing. When grading the first lab report, sometimes it's hard for me to follow. I can tell when you haven't proofread it all. You got to spend some time on this. Take it seriously. Proofread it, reread it. Let a friend read it, have them make comments, then edit accordingly. Write in a concise scientific format. Avoid pronouns. I, we, you. Don't use those. Write in a concise scientific format. Check out some scientific papers to see what kind of format you're trying to emulate. Now, don't try to write above the head of yourself or your classmates or me. You're writing for a Bio 1 audience, but using scientific format, scientific words. And don't use words if you don't know what they mean. I see a lot of students read scientific papers, take a word out of it, try to use it, but if I ask them, what does that word mean? I don't know. Well, then don't use it. If you have results that were not significantly different, that's okay. Don't say nothing happened, the end, bye. That's not a discussion. You could say, but there was a trend. It wasn't significant, but we can see that this one gained or lost heat more than this one. And perhaps with further replication, we would have a significant trend, a significant difference. But here's what we can say about the trend. It shows a difference, and here's why it might show a difference. And then go on as if the results were significant, like why would there be a difference here? If you work with someone else too closely and you obviously have worked together or plagiarized, then that's a 0 for everyone involved. So please don't do that. All right, so on the first report, remember, you can go back to that one. You can look at the comments we've made, not just the rubric, but we've made comments on that first report. You can see what errors you made and comments we made about them. But write clearly and concisely. Relate things back to biology, don't just focus on the experiment, focus on the topic. The topic is either, well, you can approach it one of two ways. The topic is thermoregulation and or surface area to volume ratios and their importance for biology. Okay. All right. That's it. That's what that second lab report will be about. It'll be worth quite a few more points than the first one. So take it seriously, and you can find the due date on Blackboard.